This is 7.2, areas of triangles. To find the area of a triangle, that is, area equals 1/2 base times height. So if I have a rectangle, I know the area of that is base times height, and to get a triangle out of it, I take half of it. I can split it on the diagonal. The height always has to be perpendicular to the base. So if it's a right triangle, it's the side. If it's this other looking triangle, the height has to go down the middle. It has to have that little box to show that it is perpendicular to the base. So we're going to find the area of each of these triangles. So I have 3 and 6, so area is 1/2 times 3 times 6. 3 times 6 is 12, and half of 12, 3 times 6 is 18, and half of 18 is 9. It's the same thing as finding the area of a parallelogram. We just take half of the answer. Here I have 8 and 12, and since the height has to be perpendicular to the base, it has to be drawn on the outside because it's such a slanted triangle. So I have 12 times 8 is 96, and half of 96 is 48. In this triangle, I have the base is 15 and the height is 4. 15 times 4 is 60, and half of 60 is 30. Here I have an equilateral triangle with the sides of 5. It's probably equilateral. That's what it looks like. It could just be an isosceles triangle. Either way, the height given is 4. We have to use the one that has the little box on it because that is the height. So 5 times 4 is 20, half of 20 is 10. Now we're going to find the missing side length. So if I'm given this information, I have the triangle, the base is 4, I don't know the height, and the area is 24. I'm still going to plug that into my formula and plug in everything that I know. I know area is 24, 1/2 stays 1/2, the base is 4, and the height is h because I don't know it yet. That's what I'm asked to find. So I need to do half of 4 is 2. Then to get h all by itself, I divide each side by 2, so the height is 12. I could plug these all back in and see if my area matches. So if I have half of 8 times 12, that's 4 times 12. 4 times 12 is 48. Half of 48 is 24. And we were told the area is 24. So since they match, I know that I did this correctly. And we have, given this information, I know the height is 8, the base is b, and the area is 32. So this is just like what I did before, but instead of finding h, I'm finding b. So plug in everything you know. 32 equals 1/2 b times 8. Half of 8 is 4, so this is 4b equals 32. To get b by itself, you divide each side by 4, and 32 divided by 4 is 8. Here I have the base is 20. I don't know the height, but I do know the area. Plug in everything you know. Half of 20 is 10. Divide 100 by 10 to get the height is 10. I can check this. 10 times 20 is 200, and then half of 200 is 100, and that's the area that's given. Now we have a composite figure, and that's a figure that is made up of 2 or more figures, usually polygons. To find the area of composite figures, we're going to separate them into shapes that we know how to find the area. Then we're going to add all of those together. By separating them, that is called decomposition. So we can use decomposition to find the area of complicated figures. So we're going to find the area of this. And I chose to split it into a rectangle and a triangle here. So with these given lengths, I know that this is 20, this is 40, this little piece is 10. I can have the area of the whole figure, the area of the rectangle, plus the area of the triangle. So to find the area of the rectangle, that's going to be 40 times 20, and the triangle is half of 10 times 20. So then I get 800 plus 100, and the area of this whole thing is 900 units.